Today in class, we talked briefly about the new formula for a slope and a point, the slope-point formula. That's a way of finding the equation in y equals mx plus b if you're given the slope of a line and you're given 1 point. Previously, we created the equation by substituting points in for x and y and rearranging for b. That method that we used in grade 9 was long and was time-consuming, so we're preferring the method that we do here in grade 10 with the slope-point formula. We can always use a graph to help us figure out the equation of a line, but when the y-intercept is below the parameters of the graph, for example, in this case, find the equation of the line through 5, 1 with a slope of 2, by the time you use your slope of 2 to go up 2 over 1 and down 2 over 1, you're going to be outside of the grid. It'll be below the graph where your line crosses the y-axis. So it's not practical to graph to find the equation of a line. Instead, we're going to use this general formula. Y equals x minus p plus q. We're going to take our point that's given and we're going to plug it in the equation for p and q. In this first example, that means 5 would be p and 1 would be q. And we would have a slope of 2, which would replace m in the equation. So we have y equals m bracket x minus p. We put negative 5 because it used to be positive, plus q. We expand using the distributive property, so 2x minus 10 plus 1 is equal to y. And we collect our like terms, so it's 2x minus 9 equals y as our final answer. So let's look at some more examples. In example 1, we have to find the equation with a slope of negative 1 going through the point negative 2, 3. So negative 2 would be p and 3 would be q. Y equals m bracket x minus p. Now our p is negative, so we're going to change it to a positive. Plus q. We're going to expand using the distributive property. So y equals negative x minus 2 plus 3. Make sure we remember our y's. And then we're going to combine our like terms. So y equals negative x or negative 1x plus 1. That's our final answer. In part B, there will be some fractions, and that's okay, we're going to work with the fractions. Y equals 1 or negative 1/3 bracket x minus p plus q. We're going to expand with the distributive property. So y equals negative 1/3 x, and then we're going to multiply negative 1/3 by negative 5. Now negative 5 over 1 gets multiplied by negative 1/3 by doing the top times the top, numerator times numerator, and denominator times the denominator. So we're left with positive 5 over 3. Now if we want to subtract the 1 at the end, it has to have a common denominator. Right now it does not. So we're going to take that fraction, negative 1 over 1, and we're going to triple it to make sure we have a common denominator. It becomes negative 3 over 3. So y is equal to negative 1/3 x. 5 take away 3 is plus 2 over 3. And that's our final answer. If we're given 2 points on the line, then we have to first calculate slope using those 2 points. So in example 2, it says find the equation through the points 4, negative 3, and negative 1, 2. We're going to use our 2-point slope formula to calculate the slope of the line between those 2 points. So our slope is y2 minus y1, 2 minus negative 3, over x2 minus x1, negative 1 minus the 4. Remember that 2 negatives turn into a positive when they're right next to each other with the double signs. So we're going to change that to say 2 plus 3 over negative 1 minus 4, which in turn gives us a slope of 5 over negative 5. We always have to reduce our slope to lowest terms. I'm running out of space here, sorry for this. So m is equal to negative 1. That is the slope between those 2 points. Remember that to find the equation of a line, it requires you to have 2 things. Those 2 things are a slope and 1 point. So now that we've calculated our slope, we don't have use for 2 points anymore. We have use for just 1 point in our point-slope equation. So we're going to choose one of the 2 original points. We're going to pick one to use. It doesn't matter which one we choose, whichever one you prefer. We're going to use that point, and we're also going to use our slope that we figured out in our equation. So I'm going to pick the point -1, 2. So y equals m bracket x minus p. Now the p here is negative, so I'm going to write +1 in the brackets, +2. I'm going to distribute my slope into the bracket, so -1x minus 1 plus 2. And that means my final equation is y equals -x plus 1. Recall that slopes of parallel lines are equal or the same, and slopes of perpendicular lines are what we call negative reciprocals. So a negative reciprocal means that you flip the fraction and you change the sign. So that's what we need to do when we're figuring out slopes of perpendicular lines. We want to flip the fraction and change the sign. So in example 3, we're looking at creating equations given lines that are parallel or perpendicular. Find an equation for the line that is parallel to the one that was given. So this equation is given to you for the sole purpose of taking out the original slope. The original slope is equal to the number in front of the x, which is -2/3. Now we're trying to find the equation of a line that's parallel to that. So the parallel slope that we would be using would also be -2/3. I'm going to put a box around it because that's what I'm going to be using in my equation. It also tells us it passes through the point 2, -4. That's my PQ in my formula. So y equals -2/3 bracket x minus 2 minus 4. I'm going to distribute that -2/3 into the bracket. So I've got -2/3 x. -2 times -2 is +4/3. This -4 over here is currently over 1. So I'm going to make sure that I have a common denominator by tripling that fraction. So it becomes -12/3. And then I'm going to simplify by combining those like terms. -4 plus 12 simplifies to y equals -2/3 x minus 8/3. And that's the final answer for example 3. Question B asks for a perpendicular line. So we are using our original line again to give us the original slope. So original slope in this case is the number in front of the x, which is -2. And then we're going to calculate our perpendicular slope, which we do by flipping the fraction, so 1/2, and changing the sign to positive. We're going to use the slope of 1/2 in our new equation. So we're also going to use the point that's given to us. Y is equal to m bracket x, change the sign, so +4 minus 3. We're going to distribute the 1/2 into that bracket, so 1/2 x. When I'm distributing and I'm able to reduce, 4 divided by 2 gives you 2. It helps to make things a little bit easier. +2 minus the 3. So it eliminates the fractions right there. Final equation being 1/2 x minus 1. There are 2 puzzle sheets that follow this note. Practice with creating the equation of a line. Make sure you do them on a piece of lined paper so that you can show all your work, and do practice those fractional slopes. Make sure you ask me tomorrow if you've got any questions.